This is the second video for the 6-1F lesson. I'm going to look at problems 5, 6, and 8. I would suggest if you feel like you know how to do these that maybe you pause the video and try them and then watch the video. They're kind of the same techniques. And it does say we're going to assume all variables represent positive numbers. So we're going to go back to more problems involving variables. Kind of like the one in the first video, there was one that had some variables. Some other tips or tricks with this, which is that if we're going to multiply 6 times 15, and then we already know that we're going to have to factor tree this to extract perfect squares, it might actually be best, and I actually prefer to do this, that we just start factor treeing here. And these are both radicans or irrational numbers. So here is a pair of threes, and out comes one. And then there are no pairs here, so I multiply 2 times 5, which is 10. So this is a more efficient way. I would encourage you to try 6 times 15 and try to take the square root of that, and you'll get the same answer. 6 times 15 should be 90, because you can see that the 3 previously was a 9 when it was extracted from the square root. So consider doing this, that if you're multiplying these and you get some horrible number, this one wasn't that bad, then maybe alternatively, you just start factor treeing from here, because a factor tree for 90 would be 6 times 15. So now 6 and 8, if you feel like you kind of have this, pause the video or try them and then double check it. 6, I know that 5 goes into 480 times. So I'm probably going to go with this technique that I'm going to do something like this. There is a common error, though, that when I cancel these, since they're both in square roots, that some people tend to forget that the square root's still there because we haven't square rooted anything. All right, and now this is just going to be over 1, which means I can kind of disregard this, and I'm going to start to look for what to do my factor tree with. I'm going to do, I think I did this problem before, and I used 16 times 5. So 16 is a 4, and 5 stays inside. Sometimes you might pick a really efficient way, and other times you might do 8 and 10 and then just keep going and pulling out all the pairs. And then I'm also going to look at number 8. Again, this might be a good time to pause because technically number 8 is a problem like the E lesson. So if you had questions on E, then you might watch this very closely. And if you feel confident, then maybe you try it and then check the video. We're going to set up our answer with our square root or radical symbol. Maybe we start with variables this time. So y to the 6th is y cubed times y cubed. So out comes one of these. I'm going to have to resize this a bit. W, we're going to do w to the 1st times w to the 6th. And this comes out, and it's just like what we did with the y, and the w stays inside. And now we've got 124. So we just pick something. 4, I think, probably goes into this. 4 goes into 12 3 times, and 4 goes into 4 1 time. So 4 and 31, and 31 is a dead end. So there is my perfect square, and 31 is inside. So my final answer, just to kind of clean up its appearance, is 2y cubed w cubed root 31w. And you can see how some of these problems kind of are just like reviewing or improving what we learned from the E lesson. And then maybe other ones like number 10 are more the new techniques or more difficult problems.